So again, when we want to describe these relationships, whether it's an equation, table, or graph, we want to have some starting point, and we need to know how it goes up or down for that matter. So a straight line, again, remember, can be described with its angle or the rate it goes up and where that line is located. And we're going to call that, or we're going to use initial positioning when x is 0 to describe that. So here Kelly earns a salary of $200 plus 8% commission on the amount of sporting goods he sells at Sport Chek. So write an equation for this relationship. Okay, so what are the quantities that we're comparing? We're comparing earnings to the amount sold. Okay, so the earnings is going to be the dependent, or y, the amount sold will be x. Okay, so what does my equation look like? It's going to look like this. Earnings is equal to, we start with $200 and we're going to add on 8% times the amount sold. Okay, and as an xy equation, we can write this as y equals 200 plus 0.08x. Okay, so let's make a table of values here. When we plug in 0, we get $200. When we plug in, let's start with 100. Actually, let's go up by more than that. Let's go up by like 500. Okay, so if I sell $500 worth of stuff, I'm going to make about 40. How much is that going to be? So for $100 is going to be $8. So for $500 it's going to be $40. So I'm going to earn $240. Let's go up to 1,000 here. $1,000, they'll earn $80 on 1,000. So we're going to end up with 200 plus 80, or 280. Let's go up to 2,000, 4,000 here. $2,000 is going to be $160, so 360. $4,000 times 0.08 is 320 plus the original 500. So original 200 is 520, and then for another $1,000 or $5,000, we're going to earn looks like $400 plus the original 200, which is $600. Okay, so we have a starting position. Okay, that's important. We need to describe slope, okay, or how it changes. So we're going to go from 500 to 1,000. That's plus $500 of sales. We end up with plus $40 of earnings. Okay, so that ratio on the outside describes my rate or my slope. How does that connect to the parts in the equation? Well, we know that there's my starting amount. Okay, there's my starting amount. Now the way I increase is by using that 8%. So that 8% then should represent the increase, the rate of increase. Okay, so let's graph this then. Let's graph this and we can answer the rest of the question here. So my scale here, I'm going to go up to 5,000. So 1,000, 2, 3, 4, 5. Okay, this is going to be the sales. Make sure you label your axis. Okay, the earnings, we're going to go up to 1,000. So I'm just going to go up by $100. This is my earnings. Okay, so it's going to be $100 of earnings, $200 of earnings, etc. We're starting at $200, so on my graph, this position is called the y-intercept. Okay, and then we're going to go up using this pattern of change. So we're going to go up for every $1,000, or $500, we're going to go up $40. So maybe about there, right? So $240 looks like it's right about there. Okay, so if I go up by 1,000, we're going to go up by 80, so $280 right about there. $2,000 is going to be 360, so 360 may be about there. $4,000 is going to be 520, so maybe right about there. And 5,000 is going to be $600 there. Notice that that's what we're looking for, is our straight line pattern. Okay, we have a starting point. We also have a ratio of change. Our ratio of change is going to be based on how it increases. And it's a ratio, so it doesn't matter if I use a big triangle to show that ratio. So in this case, from 2,000 to 4,000, I'm gaining $160, and that's over $2,000 of sales. Okay, and that ratio works out to be 0.08. Okay, so there's where my ratio of change shows up. It shows up in the triangle. So the ratio of change then, we've described it as plus $40 for every $2,000 sold. It's always the rise, our dependent variable, divided by the change in our independent variable, which is $2,000. Okay, and I should make sure it's clear. It's the change in y compared to the change in x. Okay, the change is y is on top. When I divide those to get a unit rate, I get 0.08 as my unit rate, and the units are going to be dollars earned for dollars sold. Okay, and that's important. Dollars of sales. Okay, and we can see the units right on our axis. The change in y of earnings over the change in x, which is sales. So the ratio of changes of y to x is 0.08, and I can just take that and copy that and use that to answer the question. Okay, so we're going to end up with the ratio of change. It works out to be, there it is. Okay, just move that up. The ratio of change, or the rate of change, is going to be 0.08 dollars earned for every dollar sold. Okay, so this is the rate of change in the problem. Does the rate of change show up in the equation? Well, the rate of change looks like it's showing up in the triangle in the picture. It's showing up as the ratio of change on the outside of the graph, and it's showing up as a multiplier in my equation. So I better write this down. The ratio of change and I'm going to also call it the rate of change, shows up as the multiplier in the equation. So this is a good way to recognize what part of the equation is our ratio of change or a rate, and vice versa. We can figure out where to put the rate in our equation.